Good evening, everybody, and I hope you're all sitting comfortably for the great Moon Hoax. So I'm sure you all know that the moon landings were hoaxed. Everybody knows that. All you need to do is look on the internet and you'll find 250, 500,000 web pages that all tell you about the evidence that the moon landings didn't take place. Before we get stuck into that, let's just remind ourselves what happened something of order 51 years ago.
I'm going to step off the left now. It's one small step for man, one giant leap. So, I guess you want to do it again. Okay. Sorry, this is working.
Maybe that's not quite the way you remember it, but that was take one. I guess they rehearsed it a few times before the version that you remember. So that's the idea, that the moon hoax was perpetrated and man did not go to the moon, land on the moon. It was all people, actors, jumping around in suits, either on a Hollywood sound set or perhaps in Area 51, depending on what you believe. So why do people believe that the moon hoax got started in the first place? Well, it was because Kennedy made a promise.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
And there's the four key words: impressive and important. Yep, fantastic. But difficult and expensive. And it was underestimated, either by Kennedy or more likely by his advisors, just how difficult and how expensive it was going to be. So they started in the early 60s intending to put a man on the moon, but after a few years it was too difficult, too expensive, and so it had to be hoaxed in order to save face, in order to convince the American people, indeed the world, that Kennedy's promise had been met. So no one is doubting that Saturn V rockets existed. Enough people have actually seen these things launch, unfortunately not myself, but enough people have witnessed these that you can't deny that these Saturn V rockets existed and launched. And it is generally believed that yes, man has been in space. So the Apollo hardware, you can see here the command module, the lunar module, in Earth orbit. That is not denied either. We are not saying that man has never been in space and isn't occupying the International Space Station. What we're saying is man has never got beyond that. So in other words, a photo like this, which purportedly is a man standing in front of the lunar module, this was not taken on the lunar surface, this was taken on a soundstage of some kind. And similarly, this picture taken later in the Apollo mission. Look closely, you can actually see that this is plaster of Paris in the foreground, and you can probably make out that the background is just cardboard. That's fairly obvious for just a cursory glance. So what are we going to do here? This talk is all about, let us take the moon hoax at face value. If there is so much evidence, then let's look at that evidence and see if it stands up to scientific scrutiny. What I'm going to pick out here is the fact that computers weren't up to the task, that radiation would have killed the astronauts, and I'm going to look at some video clips and some still images. And absolutely, I'm not going to pick all the evidence. I've been criticised in the past for only picking out certain bits of evidence, and yes, that's all I can do in a talk that's only going to be 1 hour long, unless you grant me 10 hours of Zoom time in order to give you the full story. So what I'm going to do is pick out the pieces of evidence that crop up most often in web pages and elsewhere. In other words, the bits of evidence that you're most likely to have seen or heard, and let's scrutinise that and see if it stands up. So firstly, let's look at computers. It's often said that computers in the 1960s were not up to the task. They were simply too big. This is a picture probably from the late 1950s, not long before Kennedy made the promise to put a man on the moon. So how on earth do you fit all of that in a box small enough to take to the moon with you? Well, basically you give the problem to the brightest people you know. You give the problem to the Massachusetts Institute of Technology and say, put all of the computing power we need into a box no bigger than about 1 cubic foot. And by the way, you've got a few years to do it, and here's a shed load of cash. Basically, that is what NASA did. The question is, at the end of the day, was that sufficient computing power to put a man on the moon? The computer you can see there, it's inside the copper box to shield it from any radiation, and you can get an idea of its size from the pad on the right hand side. Bear in mind that pad has to be used by an astronaut who might have a gloved hand, and therefore it's quite a chunky keypad. So the computing box is about the size of a briefcase, or coincidentally about the size of a modern day PC, give or take a little bit. Anybody who says the computing power was very little in those days is absolutely right. Sometimes it's been compared with the computing power available to Apollo was less than you've got in your mobile phone. That is not a fair comparison by orders of magnitude. The amount of computing power in the Apollo guidance computer would be better compared not to a mobile phone, it would be better compared to a singing Christmas card. That, roughly speaking, has the same amount of computing power. So a computer of this age could do thousands or maybe tens of thousands of calculations per second, and it could store many tens of thousands of bits of information. If you compare that to the computer that you're probably using to watch this particular Zoom talk, this computer, the Apollo guidance computer, is probably about 1 million times slower and probably can store perhaps 1 billion times less information, roughly speaking. Imagine if your computer suddenly went 1 million times slow. That would be unacceptable. But anybody who says that's not up to the job doesn't understand the job it had to do. If you've got a guidance computer, its main job is navigation, trying to work out where you are and how much you have to accelerate, how long you have to burn the engine in order to change your velocity in order to get you from where you are to where you want to be. It's effectively solving Newton's equations of motion. Newton figured it out hundreds of years ago. It's not rocket science. Okay, it is rocket science, but it's not actually that difficult to calculate how to solve Newton's laws of motion for a certain set of parameters of orbiting the Earth and then moving to the moon. It's something that we ask our first year undergraduates to do in the physics department at the University of Liverpool. And most of the time they do the calculations by hand, and occasionally they get some computer assistance. But it is not a big deal. The computer doesn't have to run Windows 10. It doesn't take 5 minutes to reboot. It is up to the task of getting man to the moon with an accuracy of a few meters, or more likely a few tens of meters. Bearing in mind that although I've put this as a piece of evidence, it's actually not a piece of evidence. Someone who says the computing power wasn't up to the job is simply making a statement. They're not presenting a piece of evidence. They're simply saying, in my opinion, the computing power wasn't up to the job. That is not evidence, they're just stating an opinion. And they're wrong. The second piece of evidence is also, strictly speaking, not evidence. It's a statement. The radiation would kill the astronauts. The Earth is surrounded by radiation belts. So we have energetic positively charged particles, protons, and negatively charged particles, electrons, from the sun, get trapped in the Earth's magnetic field and form these blue donuts, these radiation belts called the Van Allen belts, and they circle the Earth. And because we have energetic protons and electrons in this area, it is a rather dangerous place to be. And it's often said astronauts travelling to the moon would receive a lethal dose of radiation. That's perhaps a result of misunderstanding what we mean by saying that these radiation belts are lethal. It is indeed true that if you were to park a spaceship in the middle of a radiation belt, the astronauts would indeed receive a lethal dose of radiation. But the point is they didn't park there. They went through the radiation belts on the way to the moon. Of this scale, the moon would be a few meters away off screen. And as the astronauts left the Earth after orbiting the Earth once or twice, they would then go through the Allen belts, the Van Allen belts, on their way to the moon, which would be a 3-day journey. The length of time they would take going through the Van Allen belts would be, I think, about an order of an hour. So although the radiation levels are indeed quite high there, they're only being exposed for about an hour, and the total dose they would be expected to receive would be probably no worse than maybe 1 or 2 chest x-rays. I haven't shown it in this picture, but actually the Earth is tilted. It's at 23 degrees relative to the plane of its orbit. So these Van Allen belts are actually tilted over a little bit. So if you wanted to go to the moon, you don't have to go ploughing through the middle of the Van Allen belts. With a little bit of clever flight trajectory, it can be arranged that you don't have to go through the densest part of the Van Allen belts. And indeed, that was what was done in Apollo 11, and I haven't looked at the detail of the other trajectories, but that would be a sensible thing for NASA to do to try and minimize the dose. Bear in mind that the astronauts, when told you're going to go into a radiation belt and you might receive a radiation dose equivalent to a few chest x-rays, it might conceivably increase your chance of getting cancer later in life by maybe 1% or 2%. The astronauts, I would imagine, would accept that risk. Bear in mind that that's not necessarily number 1 on their list of things to worry about. Remember, they're being told that they're going to be strapped onto the top of a 3,000-ton rocket full of highly explosive liquid oxygen, liquid hydrogen, kerosene, and the rocket was made by the firms that put in the lowest bids. That perhaps is more likely to be top of their agenda for worry compared to they are definitely going to pick up a little bit of a radiation dose. So again, this is not evidence, this is a statement. Somebody has said the astronauts would die on the way to the moon. They haven't presented the evidence, they just made a statement, they've made a claim. In a sense, they've offered their opinion, and they're wrong.
Maybe it'll, that looks like it's waving in a breeze.
Let's have a look at a video.
How many times can a man turn his head and pretend that he just doesn't see? The answer, my friend, is blowing in the wind. The answer is blowing in the wind. Yes, and how many deaths will it take till he knows that too many people have died? The answer, my friend, is blowing in the wind. The answer is blowing in the wind.
A little montage there of a few Apollo missions in which the flag appears to be fluttering in the wind. So presumably this was on a sound set in which they left the door open somewhere and the wind got in and made the flag flutter. Or perhaps there's a simpler explanation. In all of these clips, perhaps you've noticed the theme that runs through all of these. In all cases, an astronaut was holding onto the flag, either trying to plant the flagpole or trying to unfurl the flag or simply trying to get it nice for a photograph. There are other pictures of flags where perhaps an astronaut is not touching the flag. There's an indication of a flag that's got moved when some exhaust from the lunar module blasted in its direction and made the flag move. But generally speaking, if you look at any video or any cine footage of the Apollo missions, if you look at a flag that is not in any way being interfered with, the flag stays absolutely stationary. So the idea of flags blowing in the breeze is simply an illusion caused by the way the flags appear to move when they're being manhandled by one of the astronauts. Let's have another look at a video which is claimed to be fake, because when the lunar module takes off from the surface, you can't see any exhaust plume from the engine.
10 seconds. Fourth stage, push. Get your arm in death. Yeah, I'm going to get the pro. 99, proceeded, 3, 2, 1, ignition. Run away, Houston. That's your good.
No sign of an exhaust plume.
Get over. Okay, yeah, get back.
Perhaps just the hint of something as it gets higher into the sky. And based on the fact that we don't see a large tongue of fire coming out of the back, some people have hypothesized that that must be a studio model on wires, on sort of a fishing rod or something. Some stagehand simply reeled it up at the right time to make it look like the lunar module was leaving the surface. This is partly based on our perception of what we would expect a rocket engine to do, because we know what rocket engines are like. I mean, that's a rocket. That is a proper rocket. Look at that white hot tongue of flame coming out of the back end of the Saturn V as it leaves the Earth. Some people have said, well, maybe that's different because this is in the Earth's atmosphere and maybe things are different in vacuum. That's not the main reason why we see things differently between what we see here with a white hot exhaust flame compared to other situations. It really depends on what the rocket fuel is rather than whether it's burning in the Earth's atmosphere or whether it's burning outside the Earth's atmosphere. So here, for instance, we're burning kerosene. The first stage of a Saturn V is burning kerosene. It's a sort of paraffin-based material. It's like aviation fuel, which means we've got hydrocarbons in there which are being burnt and get very hot, and so we have white hot hydrocarbons coming out of the back, and hence they glow white hot. If we were to take a different fuel, for instance, if we were to think about the shuttle orbiter, that burns hydrogen and oxygen, and there the rocket plume would produce, because we're adding hydrogen to oxygen, the result is going to be water vapour coming out of the back of the engines, which is essentially invisible. So if we look at the shuttle, we find that there's very little indication of a rocket exhaust. Now, you look at that and you say, hang on, surely not, I can see just as much there as I did with the Saturn V. But if you look more closely, you realise that what you're looking at is the exhaust from the solid rocket boosters on the left and right hand side of the external tank. The external tank, the orange tank in the middle here, contains the hydrogen and the oxygen, which is being fed to the shuttle orbiter, and its engines here are burning the hydrogen and oxygen. And notice that the exhaust plumes from those three engines is almost invisible. Not quite. If you look closely, you can actually see shock waves in the actual exhaust plume, which is almost transparent. Those shock waves are called shock diamonds. But it is very clear that the fuel here, which produces white hot exhaust from the solid rocket boosters, is very different from the exhaust we see from hydrogen and oxygen burning. So our perception of always expecting to see an exhaust plume is based on our preconception of what rocket fuels might be existing and what is producing that rocket thrust. In the case of a lunar module, it's not actually kerosene, it's not actually hydrogen and oxygen, but we wouldn't necessarily expect to get the very bright rocket plume that we see, for instance, in these images. Let's have a look at some images rather than some videos. This one crops up on a very large number of web pages that I've checked in past years. They talk about impossible shadows. It is said many, many times that this picture is proof that you can't possibly get shadows like this if you only have a single light source. So if we're on the surface of the moon, there's only one light source, the sun, at effectively a distance of infinity. Okay, it's not quite infinity, it's 150 million kilometers. But on the scale that we're seeing here of order hundreds of meters, it's effectively an infinitely large distance over to the left-hand side. And you might say, well, surely there's not only one light source. Isn't the Earth also shining down on the surface? Well, yes, it is. But just like here on Earth, the full moon is very much fainter than the sun. The full moon might look bright, but only because you tend to see it at night. If you were to take a full moon and put it next to the sun, which you can't do, but if you were to put them side by side, the sun would be 1,000,000 times brighter. And here, the sun would be substantially brighter than the Earth. Perhaps not 1,000,000 times, but it would be so bright we would not expect to get two shadows for every object in the field of view, one from the sun and one from the Earth. In a picture like this, we would only expect to get shadows from the sun. So where is the sun in this case? If we look at the lunar lander, we can see it's got a shadow moving off to the right. We can't actually see the shadow of the astronaut there. It appears to be just perhaps behind a little bit of a hill. But if we draw a line through that shadow, that would imply the sun is somewhere pointing in that red line direction over on the left-hand side. And if we have a look at the rocks in the foreground and do the same and draw a line through one of those shadows, we find that would indicate that the sun would have to be here. That can't be right, surely. If the sun is an infinite distance away, shouldn't all the shadows be parallel? Maybe, by perspective, they might not look parallel, they might look like they're converging at a vanishing point on the horizon, but surely the sun is not sitting where that yellow dot is. Not only that, but if we look at one of the other rocks and draw a line through its shadow, it doesn't even go to the same place. So this is, for some people, proof positive that this picture could not have been taken on the surface of the moon. It was definitely taken in a studio, and different studio lights have been pointed at the lunar module or at this rock or at that rock, and different spotlights have cast different shadows in different directions. Well, that is indeed one explanation for the image, but as a scientist I tend to employ Occam's razor, which says if you've got two explanations for a situation, the simplest explanation could easily be the right one. So one explanation is that this is a fake, but there's another reason why the shadows might do that. And rather than talk about abstract possibilities, I think the easiest way of demonstrating that is to show an example of somebody who sat down on his kitchen table and produced a little model. Here we've got a model of the lunar lander with a shadow moving off to the right. There's also a pen standing upright in the foreground, and that's there just to show that its shadow goes in the same direction. That tells us that the light source, whatever it may be, whatever this spotlight is, the light source is a long way over to the left-hand side. And what have we got in the middle distance there? We've got a few lumps of, what is this, plasticine, but it's sitting on a bit of a plasticine mound. So you can see the shadows are not lying on the flat table. The shadows are running down the side of this little bump here. And as soon as you realise that that reproduces the shadows that we've seen in the image on the centre of the screen, we realise that the only explanation you need for these rather odd-looking shadow angles is the fact that the lunar surface is not as flat as a kitchen table. There are a few lumps and bumps here, and perhaps there's a little bit of a bump here which we can't easily discern. It's not a three-dimensional picture. We haven't taken stereo images here, so we can't tell what the three-dimensional topography is. But if a little bit of a bump on the lunar surface explains the shadows, then that seems more plausible than having to invoke the idea that this cannot possibly have been taken on the lunar surface. So this, despite being very often quoted as evidence, is not actually evidence that the picture was not taken on the lunar surface. I showed this image earlier. If it is taken on the surface of the moon, where are the stars? Why are there no stars in the sky? Well, it looks like we've got a man in a white suit in front of a lunar module, and yet there's nothing there. It has been said many times that surely if it was on the surface of the moon, there's no atmosphere on the moon, therefore surely the stars would be very much brighter than they appear on Earth, and therefore they would show up. Well, actually, that's wrong for two very good reasons. If we take the first one, is it true that the stars on the moon would look brighter? Well, if you take the atmosphere of the Earth away, does it make the stars look brighter? Well, not really, no. The atmosphere doesn't absorb much of the light coming from stars. It interferes with it, it makes the stars scintillate, so the star images will jump around a little bit, so we would see the stars twinkle with an atmosphere, and if we would take the Earth's atmosphere away, the stars would then be beautifully steady. But they wouldn't actually be an awful lot brighter because the Earth's atmosphere lets through most of visible light. That's why our eyes have evolved to detect visible light, because most of the light from the sun and other stars reaches the ground, or at least reaches the cloud layer in most cases, including England. So it's not true that the stars would be brighter, but even if you assume that they're only the same brightness as they are on Earth, why would you not see the stars in the background? Well, for any of you who've ever dabbled with astrophotography, the answer is blindingly obvious. This is a picture taken in sunlight. It's never cloudy on the surface of the moon. So this was taken in sunlight. So I don't know what particular exposure was used. I would guess the camera was set to an exposure of perhaps 1/1000th of a second, and we don't actually know what the aperture of the lens was. It seems to be reasonably well exposed. So the exposure might have been about 1/1000th of a second, 1 millisecond. Any of you who've dabbled with astrophotography know that if you want to get a nice view of the sky, for instance this picture behind me of the Milky Way seen from a nice dark sky site, we would have to expose for many minutes. In some cases we might expose for hours to get a nice picture of the stars. So if we've only exposed for 1 millisecond, which is quite possible for this particular image, it is no surprise at all that we don't see any stars in the sky. The only thing we would expect to see is the Earth if we happen to be pointing in that direction. If we turn this around and say, well, if you really do believe that this was stage managed and that this is a set in Area 51, why did NASA have a black backdrop on this studio set? Why didn't they have a backdrop that actually had the stars in position? Say the people who believe in the Moon Hoax conspiracy. They didn't do that because they didn't want to get the stars in the wrong place. What they didn't want is some bozo from an astronomical society 50 years later to come along and say that photo can't be right because those stars shouldn't be in those positions. Now, if you really believe that NASA don't know where the stars should be, then you really, really have a low opinion of what NASA are capable of doing. That is for sure. Now, the astronauts left footprints, as we can see from this picture of Aldrin standing near the leg of the lunar lander. But again, this has often been shown on web pages where people say, if this is right, how come Aldrin has left footprints everywhere and his feet have sunk into the lunar soil, but this lunar module thingamajig doesn't seem to have sunk 1 iota into the soil? If you calculate what the pressure is underneath an astronaut's boot, you work out the mass of the astronaut, the mass of his backpack, another, I don't know, 100 kilos or something. If you work out the pressure under his feet, it's not so different from the pressure under a landing pad, which is about 1 meter or so in diameter, sitting underneath a lunar module that is of order 15 tons or so before it removes some of the fuel on landing. So if the pressure is similar, you would expect the lunar lander legs, the pads, to sink into the soil. So the question that's often presented when this image is shown is, why did the lunar module not sink into the soil like the astronauts' feet did? And the answer is quite straightforward. Sometimes they did. It's simply a question that you can't see it. It didn't happen in this particular case. The regolith, I keep wanting to call it soil, but it's not strictly speaking soil, it's just crushed rock. The regolith is a little bit more compacted in some places than others, and in some cases you can quite clearly see that the landing pad did end up going into the soil quite a few centimetres. So this is one example where if you're trying to make a point, if you want to show one photograph that backs up your point, you show the photograph, but you don't offer to the reader an equivalent counterpoint of, clearly this photograph shows that sometimes they do sink into the soil, so clearly it's a little bit variable. You can't definitively say they will or they won't. It depends on the soil, it depends on exactly what their speed was when they actually landed on the surface. So this is one example where if you were to look at a web page that talks about the moon hoax, you might find that image, but I very much doubt you will find that image as well, if it's a moon hoax conspiracy webpage. What about the cameras themselves? The cameras, the Hasselblad cameras, were bolted onto the chest plate of an astronaut. You can see it here in the picture. Let me just blow it up a bit so you can make it a little more clear. They're Hasselblad cameras made by the Swedish firm Hasselblad. NASA asked them to make modified versions for working on the moon. They had to stand certain extremes of temperature. They had to stand working in a vacuum. And there was no point in having a viewfinder. The astronauts effectively can't look down because of the way their spacesuit and helmet works. They can't look down at what their chest plate is showing them. NASA didn't want to have the astronauts continually holding the cameras. Sometimes they took them off and did hand-hold them, but on the whole, they wanted the cameras to be on the chest plate. And you can see that Hasselblad have arranged that the controls, the focus control, the aperture control, the shutter control, it's all manual, of course, there's no automation here, no digital photography and no automatic exposure, no autofocus. Everything had to be manually controlled, and so it had to be arranged so that the astronauts could change the focus, change the aperture, change the shutter speed even if they got rather clumsy gloves on. It's a question of just pushing paddles rather than gripping a ring and turning them. But this is not a viewfinder at the top. This is, I think, the way the film goes in and out. But I've shown you the camera because one of the points that again is shown very often as proof that this could not possibly have been taken on the surface of the moon is a picture a bit like this one. There's about a half a dozen in this category. I've just picked one that makes the point very nicely. And that is that you often see these black crosses. I'm sure you've seen them before and you tend to just ignore them. They're on essentially every, I think they are absolutely on every Apollo image. One of them is a little bit larger than all the rest. That's the one at the centre of the image. The image is actually square. I've cropped this one because I'm just interested in the lunar rover. So that's one of the reasons for having one cross bigger than the rest, is because it tells you where the centre is and whether the image has been cropped or not. But the point about these black crosses is that they exist inside the camera. You can imagine light from the lunar surface going through the lens. Before it hits the film, it goes through a piece of glass onto which have been etched all of these black crosses. So that imprints the black crosses on the film. Therefore, there should be no way that the black crosses can hide behind an object that's actually in the field of view, because the black crosses are in the camera. And this is what the problem is. If we have a look at what's going on there and blow it up a little bit, the black crosses are in the camera. Therefore, the black crosses cannot hide behind an object in the field of view. And this and a number of other examples like them are quoted as proof that this is not a genuine image. Quite how you account for the fact that NASA painted the crosses on afterwards or something, I don't know. And if they did paint the crosses in, why did they get it wrong? That's a different question. But the point is, it's been brought up as evidence that the picture has been tampered with in some way, because black crosses can't seem to disappear like that. And just like the impossible shadows, this particular impossible image, the easiest way of explaining it is not to try and come up with a theory, but simply to try and reproduce the same thing in a simple way. And that's what one enterprising individual has done. He took a picture in his back garden, and down the middle of this picture inset is a rather slightly out of focus dark washing line. And that washing line is running from left to right in front of a grey card, and in front of that is a white card. And depending on exactly how close you're sitting to your screen, what you will probably see is that the washing line is clearly visible when it's in front of the grey card. But when it moves in front of the white card, the washing line all but disappears, and then the washing line reappears on the other side again. At first sight, it looks like the washing line goes behind the white card. At the very least, it is very much reduced in intensity when it goes in front of the white card. What's happening is the white card is overexposed, and the crystals, the silver halide crystals in this case, are bleeding into the neighbouring crystals and, if you like, filling in what should be a dark stripe across the white. Neighbouring crystals are actually filling in. You actually get the same effect in a digital camera. You don't tend to notice it very often, but if you actually fill a pixel completely full of electrons, those electrons will spill over to neighbouring pixels, and so again a saturated white area can actually bleed into neighbouring pixels. It can happen in photographic film, as it has done here. It can also happen in CCD detectors as well. So when we look at this and say the black cross appears to be behind the, whatever this object is, the antenna of the lunar rover, that is simply because this object is overexposed. It is a white, overexposed object which is bleeding into the black and making it look like it's a sort of optical illusion, making it look like the black cross is being hidden by the antenna. There are other examples that can be picked out of other Apollo images. It happens whenever a white overexposed object happens to lie close to a black cross, and then you get this same effect of the black cross appearing to be hidden. Black crosses don't hide behind light grey objects or medium grey objects. If they do hide, they tend to look like they're hiding behind saturated white objects. So I must admit that is one that got me thinking. When I first saw that, the answer was not immediately obvious to me. For most other situations, you can apply a little bit of common sense and figure out whether an image is faked or real, or could have been taken on the moon or cannot have been taken on the moon. This one got me thinking because the answer was not obvious when I first looked at this. So kudos to the person who produced this little back garden experiment to show that it can happen. It's often said that because the cameras don't have a viewfinder, it is very suspicious that all of the astronauts took beautifully framed photographs. I'm sure that you know about this image. Even if I talk to youngsters, most people know about this image. Even if they weren't around in the Apollo era, very few people can deny ever having seen this picture of Aldrin taken by Armstrong on the surface of the moon during Apollo 11. But there's something wrong here. And I can tell you what's wrong by taking you back to another couple of images. Let me take you back to an image I showed you before. There's the one I just showed you, the classic poster boy Aldrin on the surface of the moon. Here's a picture I showed you before. You can see that I've cropped them differently. One is a square and one is a rectangle, and one has been blown up more than the other because I wanted Aldrin to look, roughly speaking, the same size in the two images to make a fair comparison between the two. They were taken, I think, about 1 or 2 minutes apart, or maybe even less than that. They were sequential images. You can see that Aldrin is in a slightly different stance. On the left-hand side, he's at a slightly oblique angle, and on the right-hand side, he has turned a little bit towards Armstrong so that he's effectively facing him. He's got an arm cocked at a slightly different angle, his feet are in slightly different position, and he's moved maybe half a metre to his left. But there's one key difference between these two images that tells us something is wrong. I'll just give you a second to have a think about that. When I'm giving this to a live audience, it's very interesting to see how many differences people come up with that might indicate there's a problem in terms of the way these images have been taken. The problem is that on the Apollo 11 mission, the backpack had an aerial. You can see it very distinctly on the left-hand side, and it appears to be missing on the right-hand side. That aerial is part of the radio communication. It's effectively covered in white material, it's visible from all directions, and it's sunlit. So it must be there. If his aerial had fallen off or folded down and he wasn't able to communicate with Armstrong or the mothership or Earth, they would have scrubbed the mission. Being out of radio contact is a serious problem. So the aerial basically is there. And if it's there, it should be visible. It's visible on the left, it's not visible on the right, perhaps 1 minute later. So what is the problem? We get a second clue as to what the problem is if we have a look again at these grey crosses. I realise that you possibly can't see these grey crosses very clearly, depending on whether you're sitting right in front of a laptop or whether you're looking at a TV from a few metres away. But the largest cross is actually down here. The largest cross in this image is there. And remember, I said that these fiducial marks, these black crosses, are there to tell you where the centre of the image is. That red circle is very clearly not in the centre of the image, and that gives us the second clue as to why that is not the image of Aldrin taken by Armstrong on the surface of the moon. The actual picture of Aldrin was that. That is the image that's in the NASA archives. But what you tend to see, and what was on the front of Time magazine, and what tends to get circulated around the world and all over the place, is that image. NASA said, that's a wonderful image of Aldrin, it's beautifully posed, it's got Armstrong reflected in the visor, it's got the lunar module reflected in the visor. That is the poster boy image that we want to use. What a shame that he's cut his antenna off. Sounds like a euphemism, but not in this case. So they said, that's the one, let's look at the previous picture, that's the one we just looked at, let's look at the next picture. No, Armstrong had moved on to do something else. He had taken a picture of the regolith or an experiment or the lunar module or something. He didn't take a second image of Aldrin in that pose. So NASA wanted to use that image, but they thought that having Aldrin pushed up against the top of the image did not make as good aesthetic framing. So what they did was move Aldrin down and add a black strip at the top of the image. They didn't have to worry about the stars. There aren't any stars in the background, so they didn't have to worry about painting the stars back in the black strip that they added. I'm sure they had the conversation, what do you reckon? Should we put the aerial back in again? The aerial that's been chopped off by this bad framing, should we add it in? You can't use Photoshop, not in 1969. Was it worth printing the image and then getting an artist to very carefully put the antenna back in again and then re-photograph the shot? Well, they decided not to. After all, who's going to notice? It's not as if 50 or 51 years later anybody is going to draw attention to this particular fact that this image in fact has been doctored. As far as I am aware, this is the only image that NASA has doctored, and they did it precisely for the reasons I've just given, aesthetics, not for any scientific or other reason, purely because they thought that was a better image than that. So in answer to the question, how do they get the framing right? They don't always get the framing right. In this case, Armstrong took a picture of Aldrin's foot. Perhaps Aldrin was on slightly higher ground. Perhaps Armstrong was leaning forward slightly because he's got 100 kilograms of backpack and life support that is tending to pull him backwards. Yes, I know it doesn't weigh the same on the moon, but still, in terms of where his centre of gravity was, that would tend to make him lean forward to compensate for the weight on his back. So maybe that's the reason. On the whole, they did a good job of pointing in the right direction. Occasionally, they get it wrong. So anybody that says, how did they get perfect framing every time? Look in the NASA archives, you'll find loads that are badly framed. They're just not the ones you tend to see in magazines or on the internet. So we've been talking about proof. The question remains, how do you prove they went to the moon? I've been talking about the evidence that people who think the landings were hoaxed, they've presented a whole load of evidence. I've taken some of that evidence and said none of it stands up to scrutiny. So you can turn that around and ask yourself, is there any evidence that can prove beyond any reasonable doubt that the moon landings did take place, rather than try and show that the evidence that they didn't doesn't actually stand up to scrutiny? Well, actually that's quite tricky. Proving things beyond any reasonable doubt is difficult. Scientific proof is absolute, and that's almost impossible to do. Proving beyond any reasonable doubt depends on your definition of reasonable. What about the hammer and feather?
Well, in my left hand I have a feather. In my right hand a hammer.
Hammer.
I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? That proves that Mr. Galileo was correct in his findings.
So the hammer and feather, some people regard this as proof. Some teachers show kids this and say, here's proof that they're on the moon, because the hammer and feather experiment, if you try that on Earth, the hammer hits the ground first and the feather takes a little longer to arrive at the ground, and therefore this is proof that it was done on the surface of the moon. But no, that's not really proof, for a number of reasons. Some people have argued, well, all you need is to do this on Earth, but you have to do it, yes, you can't do it in an atmosphere, because then the feather would fall too slowly. So all you need is to put your actor into a huge vacuum tank. It would have to be enormous, but what the hell. Let's just assume you can build yourself an enormous vacuum tank and evacuate the entire soundstage, and then you can reproduce this experiment. But there's another angle. How do we know that's a feather and a hammer? We only have his word for it. And he's a NASA employee, so of course he's going to lie about it if you didn't actually go to the moon. How do we know that feather is a feather? How do we know it's not a piece of lead painted white to make it look like a falcon feather? How do we know that's a hammer, not a piece of polystyrene? So we don't really know what the experiment is. We're just taking somebody's word for it, and even then it is possible, it's unlikely, but it's possible to reproduce that particular experiment on Earth. So no, that's not proof. The closest thing I can find to proof is this. It's part of a video, no sound in this particular case. It's part of an extended video of an astronaut driving the lunar rover over a considerable distance. And the reason we are convinced that this was done on the surface of the moon, or a number of us are convinced this was done on the surface of the moon, is I can't show you here, but if you were to look in detail at the original frames of the image, as the wheels turn, they kick up dust, but the dust doesn't billow like it does in an atmosphere, like on Earth. Each little grain of dust that gets kicked up by the wheels ends up moving in a parabola. Basically, as close as you can tell within the resolution of each frame of the image, every particle appears to move in its own parabola as it gets kicked up. There's no sign of any of the billowing you would expect if this was done in an atmosphere or a partial atmosphere. So this was done in a vacuum. And when you consider how far the rover seems to have moved over many hundreds of meters, and I can't remember if it loops back again, but it would have to be, if you wanted to reproduce this in a vacuum tank, it would have to be a vacuum tank hundreds of meters in size. I'm not sure quite how deep it would be, and then it would be height as well. It would be an enormous volume that you would have to evacuate in order to try and produce this movie on Earth. When you think of the technology available in 1969, I believe, and many people have said, and I can quite understand this, that the technology required to actually reproduce that as a fake on Earth would be more difficult than actually putting a buggy on the moon and actually running that under lunar conditions. So not proof, but it would be so difficult to fake that in 1969. These days, of course, you can fake anything in a video using whatever tools, software tools you have available. But in 1969, that would have been so difficult to fake, I think it would have been easier to put a man on the moon. Other people have said, well, aren't the reflectors on the moon, aren't they proof that they did go there? These reflectors have been reflecting lasers from the Earth to the moon, back to Earth again. That timing, pulse a laser and see how long it takes to go to the moon and back, bouncing off these various reflectors dropped by a few Apollo missions. These experiments, these timing experiments, have been done, I think, every day since Apollo 11. And therefore we have a very accurate indication of what the distance to the moon is. We now know the distance to the moon accurate to within a few centimetres, and we've measured that effectively every day for decades. So we have a very good understanding of gravity and how the moon, not only in terms of its distance from the Earth, but how it's librating and how it's nodding and how it's nutating. All of the subtleties of the gravitational interaction between the Earth and the moon have been studied thanks to these reflectors. But no, that's not proof that we've been to the moon. It's only proof that some reflectors exist on the surface of the moon. Some people would argue, well, they've been put there by automatic space probes, robots of some kind. We've sent satellites out there and they've dropped these reflectors onto the surface at some key points. And all we're looking at is the proof that these reflectors exist, not proof that men put them there. So again, it's a nice idea, but it's not proof. Others have said, why doesn't NASA just turn the Hubble Space Telescope on the moon at one of these landing sites, or all of the landing sites, and take images of the lunar module sitting there? That's been said for many a long year. I think that's been said since about 1990, when the Hubble Space Telescope was launched. And the fact that NASA haven't pointed the telescope at the lunar landing sites has been again quoted as proof that the landing sites are not there, because otherwise NASA would have pointed the Hubble Space Telescope at those landing sites. Well, that's not true, because regardless of whether you believe in the moon landings or whether you believe the landings were hoaxed, everybody has one thing in common, and that is everybody has to obey the laws of physics, regardless of what you believe. And if you work out the resolution of the Hubble Space Telescope, Close your eyes now if you don't like a few numbers popping up. But the resolution, the smallest angle that can be resolved by the Hubble Space Telescope, the angle is given by the wavelength of light over the size of the mirror, the diameter of the mirror. Wavelength of light is about half a micron. The size of the mirror is about 2.4 meters in diameter. And if you divide one by the other, you find that the smallest angular size that you can resolve with the Hubble Space Telescope is about 0.2 millionths of a radian. And I'm sure you don't like radians. So there we are. It's 10 millionths of a degree, which sounds like a tiny, tiny, tiny angle. So surely it will be able to see that. If you're an astronomer, then you might think in terms of arc seconds rather than degrees. So let's convert that into arc seconds. 0.05 arc seconds is the resolution of the Hubble Space Telescope. But you sometimes forget how far away the moon is. If you wanted to see an object, let's say for the sake of argument, 4 meters across, about the size of the lunar module, an object 4 meters at a distance of 400,000 kilometers, if you work out that triangle, if you like, 4 meters on the fat end, and imagine an isosceles triangle now 400,000 kilometers long, what's the angle of that triangle? It's about 0.01 microradians, or 0.002 arc seconds. The size of a lunar module, the angular size of the lunar module as seen from the Earth, is way too small to be seen by the Hubble Space Telescope. The lunar module is too small by a factor of 30 or there, the difference of those two numbers, the resolution of the Hubble Space Telescope compared to the size that we would need to be able to see. So the lunar module is too small by a factor of about 30, or another way of thinking of it, we'd have to have a telescope in Earth orbit with a mirror 30 times bigger, not a 2.5 meter mirror. It would have to be a mirror about 100 meters in diameter to even stand a chance of seeing the lunar module. Not talking about the flag, not talking about the footprints. This is just to see that there's a lunar module sitting at Tranquility Base and the other landing sites. So that's why NASA don't point the Hubble Space Telescope at the moon to see the lunar module. They understand the laws of physics and they know that the Hubble Space Telescope hasn't got a chance. It's a fantastic telescope. It can see galaxies on the other side of the universe, but it does not have the resolution to see a lunar module sitting on the moon. And that's why they have never pointed the Hubble Space Telescope at the moon for that purpose. I showed this image a little while ago when I was talking about the camera. Let me just make it bigger. We can see that the sun is shining over the astronaut's right shoulder and it's producing some flare. The lenses in the 1960s sometimes would produce reflections of the elements of the lens, and because the sun is shining into the lens, there's a sort of pentagon here, which is the shape of the iris of the lens, and there's a little bit of flaring here as well. So there's a blob, a couple of lines, and a big pentagon there. But apart from that, there is something very wrong with this image. Again, I'll give you just a few seconds to think about it. Some people come back with, what about the aerial? The aerial is there. It's a little bit faint in this particular image, probably because the image here is so bright on the left-hand side because of the sun, the aerial doesn't show up too well. But there is something definitely wrong with this image. Think about how many astronauts there should be. 1 in the command module, 2 on the surface. So if this is Alan Bean, and in the reflection on the visor we can see the person taking the picture, Pete Conrad, who's this joker on the left-hand side there? How can there be 3 people on the surface of the moon at any given time? So you might conclude that this image must be a fake. And in this particular case, yes, it is a fake. And I can say that with absolute certainty because I faked it. I downloaded a picture from the NASA archive, and the picture of Alan Bean taken by Pete Conrad downloaded from the NASA archives is not this one, it's that one. That is the picture on the NASA archives. I took that image, and if you look at the space on the left-hand side next to Pete Conrad, where there's a very convenient gap, I simply placed another astronaut. I found another picture of an astronaut. I don't even know if it's the same mission. I think it's probably a different Apollo mission. He was the wrong way round, so I flipped him over. He had the wrong contrast, so I adjusted the contrast. He had the wrong height, so I changed his height. And I placed him such that his shadow was just about convincingly in the right direction compared to everything else in the field of view. I then tidied up the horizon behind him, and what we have is the original picture and my version with an extra astronaut. The original, my version. The original, my version. The original, my version. With a piece of graphic software, whether it be Photoshop or other software is available, it is so easy to fake an image with digital imagery these days. It took me a few minutes just to find the relevant material and paste it in and then tidy it up. And what you end up with is an image where if you look really, really, really closely, you can hardly tell that it has been faked. It is so difficult to tell if a digital image these days has been faked, and the same is obviously true of video. You only have to go to the cinema these days and see dinosaurs roaming the earth to know that the quality of digital imagery and CGI these days, computer generated imagery, is so good you simply cannot tell whether it's real or whether it's fake. Which is a bit of a shame, because it means, well, when I was growing up, if you wanted to know if something was correct or not, you would look it up in Encyclopedia Britannica and that would tell you the answer. It's either real or it's not. These days, you look at information on the internet, you have no way of telling whether or not an image is a real image or whether an image is the result of somebody's imagination. And therefore, the age of innocence is gone. You simply have to distrust everything you see, unless it really doesn't matter. You cannot take anything you see on the internet and treat it as if it was real, not if it matters. You have to always question what it is that you're looking at. So what's the point? Why are there so many people who seem to believe the moon hoax? Why are there hundreds of thousands of web pages that continue this idea that here's the evidence that the moon landings didn't take place? Do the people that put these images up really believe that their scientific evidence is scientific? We've only looked at a very small amount of evidence. I've only looked at a few % of all of the images and statements that are out there. It's very easy to look at that and to show that it does not stand up to scientific scrutiny. But do the people who put it there, do they really believe that? Or are they just trying to get more hits on YouTube? Virtually all arguments can be countered with some basic physics. In some cases, it's not even that. It's not even physics, it's just common sense. And so if you do the analysis of the evidence, it actually makes a good science lesson. I'm pleased to see that some teachers do actually use this idea to teach kids about the scientific method. If this person is making this claim, and this is the evidence they're showing, can we look at that evidence and can we decide whether their evidence actually backs up their claim or not? Does it support their hypothesis or not? So you can actually teach the scientific method using these sorts of images and these sorts of claims. So thinking about why things might behave differently on the moon can sometimes also teach us about physics on Earth. So next time you see this image, especially if you're with somebody that's not been listening to this talk, you can say that you know that is not the image of Aldrin taken by Armstrong on the surface of the moon, and you can tell them why. Thank you for your attention.